Welcome everyone. In this explainer, we're going to quickly and clearly revise the entire height and distance chapter. Our goal? To get you totally ready for your exams. No fluff, just the essentials you absolutely need to know. So, let's start with a puzzle. How in the world do you measure a skyscraper without a giant tape measure and without ever leaving the ground? It seems impossible, right? Well, the answer is actually just simple trigonometry, and by the end of this, you'll know exactly how it's done.
Okay, let's dive in by building our essential toolkit. Before we can even think about solving problems, we've got to master these core formulas. Think of this as the foundation for, well, everything that comes next.
This little table right here, this is your best friend. These are the values for the three key angles, 30, 45, and 60 degrees, that are going to pop up in pretty much every single problem. You have got to commit these to memory. No way around it. And of course, here are the ratios themselves. Just remember the classic mnemonic, SOHCAHTOA, and keep two simple rules in your head. The side opposite your angle, that's the perpendicular. And the side opposite the right angle, that's always the hypotenuse. Easy.
All right, so we got our tools. Now let's figure out how to actually use them. The next step, and it's a big one, is turning those confusing word problems into simple, solvable diagrams. And it all starts with two key concepts.
And this slide just makes it crystal clear. It's all about your line of sight. If you look up from the horizontal, that's your angle of elevation. If you look down, that's your angle of depression. Simple as that. Look up, elevation. Look down, depression. Got it? Good.
So let's see how this all comes together, shall we? We're going to take a classic exam-style problem and just break it down step by step so you can see the logic in action.
Okay, here's the typical problem. Now, the first and most important step, and I can't stress this enough, is to translate these words into a picture. So let's visualize it. We've got a tower, we've got someone looking at it, and then they walk back 50 meters. Now they're looking at it from a different angle. Our mission? Find that tower's height.
Let's focus on that first smaller triangle. The angle is 60 degrees. Now, we need to connect the height, h, which is the perpendicular, to that unknown distance x, which is the base. Perpendicular and base. That means we use the tan ratio. This gives us our first equation. H equals x times the square root of 3.
Now let's look at the bigger triangle. The crucial point here, the part you can't miss, is the base. It's not just 50, it's the total distance, our original x plus the extra 50 meters. So we apply the tan ratio again, this time with the 30-degree angle, and bam, we've got our second equation. Now for the fun part. We have two equations and two unknowns, which means we can totally solve this. Let's just take that expression for h from our first equation and plug it right into the second one. A little bit of algebra later, and we find out that the initial distance, x, is 25 meters. But wait, we're not done. The question asked for the height, remember? So we just plug our shiny new value for x back into that first equation, and the final height of the tower is 25 times the square root of 3 meters. See? When you break it down, it's just a clear, methodical process. You can do this.
Now, here's a little secret for you. Most of the complex problems they throw at you, they're just different versions of a few common patterns. Let's call them blueprints. If you can learn to recognize the blueprint, you're already halfway to the solution. Let's check out the most common ones. First up is the moving observer blueprint. And guess what? This is exactly the problem we just solved. You'll spot this one anytime you see two angles of elevation or depression from two different points along the same line.
Next, we have the opposite sides blueprint. For this one, picture two people on opposite sides of a river, both looking up at the same tree on the bank. This creates two separate right-angled triangles that just happen to share the same height. You'll solve each one and then probably add the bases together.
Oh yeah, this one is super common, the two-tower scenario. The trick here, the key to the whole thing, is to draw a horizontal line from the top of the shorter tower straight across to the taller one. That move right there creates the perfect right-angled triangle you need to solve the problem.
And finally, we've got the same base point blueprint. You'll see this setup when you're looking at two different points on the same vertical line from a single spot. Think looking at the top and bottom of a flagpole that's on top of a building. This creates two triangles that share the exact same base.
Okay, let's bring this all home. If you're walking into that exam, what are the absolute most critical things you need to remember to guarantee your success? Let's boil it all down.
It really just comes down to this. Number 1, know SOHCAHTOA like the back of your hand. 2, memorize that table of values for 30, 45, and 60 degrees. It's non-negotiable.
And 3, the golden rule. Always draw the figure first. A correct diagram is literally 90% of the solution.
So there you have it. You've got the toolkit, you understand the core concepts, and now you can recognize the patterns. The only question left is, with all this knowledge, are you ready to go out there and measure any height, any distance they throw at you? Yeah, I think you are.